Autophagy, the body's intrinsic process for cellular cleanup and repair, is highly sensitive to nutritional inputs, particularly carbohydrate intake. While fasting and calorie restriction are well-established triggers of autophagy, the opposite is also true. Chronic overfeeding, especially with high carbohydrate loads, can suppress autophagic signaling. But this suppression is not binary. It operates along a spectrum, depending on the amount, timing, and quality of carbohydrates consumed. Understanding where the metabolic cutoff lies. When carbohydrate intake tips the balance from promoting cellular renewal to blocking it, has important implications for longevity, metabolic health, and anti-aging nutrition. At the heart of this suppression is insulin. Carbohydrates, especially those with high glycemic load, are the most potent stimulators of insulin secretion. When glucose floods the bloodstream, the pancreas responds by releasing insulin, a hormone that signals nutrient abundance and promotes anabolic processes, growth, storage, and synthesis. One of insulin's downstream effects is the activation of the mTOR, mechanistic target of rapamycin pathway, a central nutrient-sensing mechanism that directly inhibits autophagy. In essence, mTOR interprets high energy availability as a signal to halt cellular recycling. Thus, when insulin and mTOR are elevated, whether from a single high-carb meal or sustained high-carb diets, autophagy is dialed down or completely shut off. The cutoff point at which carbohydrate intake suppresses autophagy likely varies by individual, but several studies and metabolic models point to general thresholds. For most people, carbohydrate intake above 150 to 200 grams per day, especially when spread across multiple meals and snacks, maintains consistently elevated insulin levels and prevents the fasting-like conditions needed to activate autophagy. In contrast, carbohydrate intake below approximately 100 grams per day, particularly when combined with time-restricted eating or exercise, can reduce insulin exposure enough to allow periodic activation of autophagic pathways, particularly overnight or during post-absorptive windows. Even more powerful are very low carbohydrate or ketogenic diets, which typically keep carbohydrate intake below 50 grams per day. At this level, the body enters a state of ketosis, producing ketone bodies that serve as alternative fuels and act as signaling molecules to promote autophagy and stress resistance. Ketosis is associated with lower insulin, higher glucagon, and increased AMP/ADP ratios, all factors that trigger AMPK activation and inhibit mTOR. This state mimics some of the metabolic benefits of fasting, even in the fed state, and is particularly effective at initiating mitophagy, the autophagic recycling of damaged mitochondria. But it's not just about how many carbohydrates you consume, it's also about when and what kind. Carbohydrates eaten earlier in the day, particularly as part of a single meal or within a short eating window, have a less pronounced effect on autophagy suppression than frequent snacking or late-night eating, which prolong insulin elevation and delay the onset of the fasting state. Moreover, complex carbohydrates with low glycemic indices, such as those from vegetables, legumes, and intact whole grains, produce smaller, slower glucose and insulin responses compared to refined carbohydrates like white bread, sugary snacks, or processed cereals. This means that the quality and timing of carbs can modulate autophagy activation even when total intake remains moderate. Another overlooked variable is the interaction between carbohydrates and other macronutrients. High-carb diets that are also high in protein can synergistically stimulate mTOR, especially through branched-chain amino acids like leucine. This dual input, glucose from carbs and amino acids from protein, creates a metabolic environment that is deeply anti-autophagic. On the other hand, combining low-carb intake with moderate protein and higher fat can minimize mTOR activation and shift the balance towards cellular maintenance rather than growth. Interestingly, the suppression of autophagy by high-carb intake may not always be harmful if balanced with cycles of nutrient deprivation or energy demand. The body is naturally rhythmic in its autophagy activity, often peaking during the night or during prolonged gaps between meals. The problem arises when carbohydrate intake is consistently high, without interruption, for weeks or months on end. In this chronic fed state, autophagy is rarely activated, leading to the progressive buildup of cellular damage, mitochondrial dysfunction, and inflammation, all hallmarks of aging. From an anti-aging and health optimization perspective, the practical takeaway is not necessarily to avoid carbohydrates entirely, but to structure their intake in a way that allows for regular, predictable windows of autophagic activation. This could mean maintaining a moderate carb intake, perhaps 75 to 100 grams per day, focusing on low glycemic sources, and pairing this with intermittent fasting, overnight fasting windows of 14 to 16 hours, or periods of low-carb days to reset the metabolic environment. It's also wise to avoid the pattern of constant snacking or late-night eating that keeps insulin levels perpetually elevated and autophagy suppressed. In conclusion, high-carbohydrate diets can significantly suppress autophagy by maintaining insulin and mTOR activity in a chronic anabolic state. While there is no universally fixed cutoff, most individuals are likely to exceed autophagy-inhibiting thresholds when carbohydrate intake consistently surpasses 150 to 200 grams per day, especially with frequent eating patterns and poor food quality. Balancing carbohydrate intake with periods of metabolic stress, whether through time-restricted feeding, exercise, or carbohydrate cycling, offers a more sustainable strategy. Ultimately, the goal is not to eliminate carbohydrates, but to consume them with precision and timing that support, rather than inhibit, the body's built-in mechanisms for repair, regeneration, and longevity.